Thank you. I was asked to prepare some slides about project applications. One project application which we wrote last year was about collaboration between 5 universities in the Baltic region. The project was called Photonics Balticum. It was rejected and we are planning resubmission now in May. It's basically on satellite ranging technologies and quantum optics. Another project we wrote last year for Latvian evaluation, it was involving distance ranging using femtosecond frequency comb. And basically we saw that such method is working by reading publication from NIST. And in Latvia we have good possibilities with telescopes and satellite ranging, so we thought maybe we can improve situation even more. And the idea is that femtosecond comb, which has broad spectrum and different colors, they go in air with different velocity because of dispersion. And by measuring transit time of different colors, one could estimate atmospheric layer thickness, which could improve the laser ranging precision of satellites in future. But first experiments would be in laboratory scale, maybe 10 meters or 30 meters. Then another application was with Lund University. They are working on future emerging technology of combining optical and ultrasound technology. They have developed filter using slow light, and this filter can filter out ultrasonic sideband, which is only 100 megahertz away from the laser line. This project application is currently in evaluation, so we will see. It's a big hope. And meanwhile in Latvia we were doing also some smaller projects. One was about laser-based airborne dust counter. In the center of Riga there is a problem with small dust flying around, and one can see it very well in the strong laser beam. And only counting dust, it does not help. We also need to clean the air. So we found out that by using anti-allergy labeled vacuum clean air bags, we can clean air in the laboratory space around 10 times. Another project was concerned with optical image processing. It started as a project to monitor laser from home, if it's running or not. And later we learned how to recognize digits of some analog meters or electricity counter or oven temperature, and get into computer, digitalize, and then it can be seen from internet if everything is working. And this technology, it's very modern now. Many groups in Europe are working in this field. One can do, for example, remote health monitoring by looking at patient's hand or human hand. One can see small variations in the reflected light caused by blood flow, and can make optical pulse measurements contactless. And presently computers are becoming more powerful, and image processing technologies. On this slide one can see dust flying around in the lab, and on another slide it's already processed, and one can identify particles of dust. And in Latvia we can do some small projects, and of course one should not forget the big goal. And the big goal is physics, something which remains for a long time. And this is, for example, a project with Zurich, collaboration with positronium spectroscopy. Positronium, it's composed of positron and electron. It has no proton size, so one can do quantum electrodynamic calculations and without proton size effect. Another topic why it's interesting, it's not known still if it's same direction of gravitation for antimatter or opposite. When particles are charged, electric fields, they are much stronger than gravitation fields. So only with neutral antimatter atoms one can do such tests of gravitation. And gravitation idea, it was not to measure direction of fall, but shift of energy levels in gravitation field. And to see if shift is as for normal matter or if it's opposite, one would need to improve precision of measurement 25 times, which is probably for all the life enough to do. So that's all. Thank you for attention.